So for the section 3-4 for pre-calc, one of the topics that you guys are going to be looking at here is just being able to solve any of the log equations that I give you with no suggested strategy. They're just going to say solve these things. The best advice I can give you guys is, when in doubt, translate it. And what I mean by that is, looking at these first three, they're all written in exponential form, meaning that there's no logarithms present. When you're given that, and you're not sure what else you should do, first thing is try translating it. Okay, so translate it. Log base 5 of 625 equals x. And let me grab my handy dandy calculator. I know I can't show you guys it, but let's see. I'm looking for log. I'm going to do change of base. 625 divided by log. Woo, that seemed particularly bad handwriting. Let me get rid of some of this. Log 5. So log 625, make sure you close the parenthesis, divided by log of 5. It's 4. Okay, so that's all you're going to do. This one, try translating it. So that would be log base 1/2 of 32 is x. Pick up your calculator, type it in. I think x is equal to -5, if I'm not mistaken. I'll try it quick, because I hate to send out this video and you guys get, hey, Kesnick, you got that one wrong. Well, let's see, divided by log of 0.5. Yep, -5. Whew, got right for a change. Okay. This one, translate it. Log base e of 2 is x. I won't let you guys leave your answers that way, so that's the ln of 2 is equal to x. Now notice, solve exactly. So, if you were to type that in your calculator, you're going to get some really funky weird decimal. I don't want a funky weird decimal. I want an exact answer. So you leave your answer right there. You don't go any further. Translating these, again, when in doubt, translate them. So, if you need to do that intermediate step, log base e of x is -7, then you get e to the -7 is x. Again, I'm looking for exact, so don't type it in your calculator, leave it as is. When in doubt, translate. 4 cubed is x. I'd be happy, tickled pink, whichever, if you guys left it right there. You don't have to go any further. If you want to type it in and tell me what 4 cubed is worth, that's just fine. Next one. So, translate it. X to the 4th is 625. You need to solve for x, so here you're going to take the 4th root of both sides. Look at that, it didn't close into my 4s. Is that going to be 5? Let's try it. 4th root. Now remember, some of y'all are going to go, well, how do I type that in your calculator? Remember, you can go second math. Is it second math? Hold on. No, I lied. Once again, proved wrong. Okay, here we go. On your calculator, because I don't usually use those functions, that's why I'm feeling kind of rusty on it. You want the 4th root. You have to type 4, then hit the math button. Then it's option 5, and it will produce the 4th root for you. It may write it like this, okay, with an X sitting there. And it means that the number that comes before it goes there, then you type in 625. Personally, I'd avoid this whole issue altogether by just typing in 625 raised to the 0.25, raised to the quarter. In other words, 625 to the 1/4 power, and avoid the whole issue. So 625, whoops, 625 raised to the quarter, yep, 5. So once again, I win. All right. Solve exactly. When in doubt, translate it. Well, no, that is solved exactly if I'm doing, because the only way to get an answer for that is doing change of base. So I'm asking you to solve exactly. There's nothing else to do. If I were to ask you to round this to the nearest 100th or something like that, then yeah, you would type in log of 4 over log of 3. But since I'm asking for an exact answer, it's looking, I mean, because this is what it wants. 3 to the what power is 4? There isn't a nice number that's going to give you an answer for that. So if I'm looking for exact, there's nowhere to go. Same thing with this one. There's nowhere to go. That is exact. If I wanted a decimal, then once again you do change a base. Okay? But since I'm looking for exact, you're done. This one, translate it. If you need to do the intermediate step by writing log base e, that's fine. But remember, log base e is ln, so the ln of 7 is x, and you're done. You don't have to type it in your calculator because I want it exact. Okay, there's a couple different ways you can do it. One is translate. Log base 2 of 16 is equal to 2x plus 1. Remember what this is looking for. 2 to the what power is 16? It's looking for 2 to the what is 16. Oh, that's a heck of a 16. So if you guys remember your powers, that would be 4. 2 to the 4th is 16. So 4 is what this is worth. So 4 is equal to 2x plus 1. Subtract the 1, divide by 2. Okay. Now there's a way you can do it without using any logarithms. 16 is 2 to the 4th. And this idea works on, in order for these two statements to be equal, their exponents have to be equal. So you can just go to 2x plus 1 is equal to 4 and solve it from there, and you get the same answer. In other words, you're jumping right to the step right there. Okay, this is log base 10 of 10 to the 6th. It's asking 10 to what power is 10 to the 6th? So yeah, it's a trick question. 10 to the what power is 10 to the 6th? You're right, it's 6. Okay, this is asking the same thing. 10 to what power is 10 to the 3x minus 5? Again, that's kind of a trick question. 10 to what power is 10 to the 3x minus 5? Or a trivial question. 10 to what power is that? Well, the answer is 3x minus 5. So what I want you to see is when the log of the base matches the base of what's inside, they cancel out. So this is going to cancel this, so you answer 7. This is going to cancel this, so you get 2x plus 1. ln cancels e, so you just get 5. ln cancels e, so you just get 5x plus 4. This, I wouldn't put it back up as a power here, I would divide it out. So log base 10 of x minus 6 is equal to 11 fourths. When in doubt, translate it. So remember the base is 10. 10 to the 11 fourths is equal to x minus 6. Add the 6 and you're done. 10 to the 11 fourths. Ooh, both my 11 and my 4. Holy cow. Looks like almost some Russian symbols. 11 fourths minus, plus 6, because I'm adding it over, equals x. So I added the 6 over, and you got it. Okay, this really long-winded one. All right. This is a product. Sorry, it's a sum, so you can bring it together as a product. So log base 3 of x times x squared minus 8 equals log base 3 of 8x. Now, one easy answer for this is the only way these things are going to be true is if this is going to be equal, is if what's inside them are equal. So I'm going to bring it together, or sorry, just take it apart, that the x cubed would disappear. That if these are going to be equal, the only way they're going to be equal is if what's inside them is equal. I'd love it if I could divide this 8 out, but I really can't. Sorry, the x out, I really can't, because you could be dividing by 0. So unfortunately, you have to distribute it inside. Subtract this 8x over, so I get x cubed minus 16x is equal to 0. There's an x in common, factor it out now. So x squared minus 16 is equal to 0. Now it's a 0 product property. We've been practicing this thing all years, and even back in Algebra 2, we did it a lot. Add the 16. Take the square root. Okay, now let's look back at this for a second. Yep, the base isn't the variable, so I'm okay to have some negative answers. Okay, so those would be your answers. I don't think there's anything else on the next page, so there you go.